Okay, so here's the problem. F of negative x equals x squared plus 2x plus 4. Now, what the problem wants you to do is evaluate at negative x this function, and then we assume that we will then factor the evaluated function, which will actually just be another function since the term here, the input, is itself an algebraic expression, negative x. So we'll then factor it, set each factor equal to 0 and solve. Okay, so that's the steps. So what we're going to do is we're going to write f of negative x equals, now it's very important to use parentheses here. We're going to put negative x, parentheses, and then square that, plus 2 times, again, parentheses, negative x, close parentheses, plus 4. Okay, so now we're going to simplify this out. F of negative x equals, now anything squared is positive, so negative x squared is just x squared. And now we have 2 times negative x, which is minus 2x, and then plus 4. So what we need are two numbers that add to equal the middle term and multiply to equal the last term. So they have to add to equal negative 2, and they have to multiply, those same two numbers have to multiply to equal 4. Okay? Now, there may not be what we would call a simple solution here. We may have to use either the quadratic equation or completing the square, but we'll give it a try, okay? So first, let's just see if there's anything that obviously works. Two numbers that add to be negative 2 and multiply to be 4. Well, if I look at 4, we don't have that many factors, right? It can be 1 and 4. It can be negative 1 and negative 4, right? So those multiply, both of those multiply to be 4, but this adds to 5, that doesn't work. This adds to be negative 5, that doesn't work. And now we get down to the other two factors, which 2 and 2, and negative 2 and negative 2. Well, 2 plus 2 is 4, and negative 2 plus negative 2 is negative 4. So in all cases, our attempts to simply factor fail. So that means that this cannot be simply factored. And it likely means, not for sure, but it either has not, well, it certainly does not have what we would call integer solutions. So we either have, fractions, decimals, stuff like that, or we have complex solutions. So there are definitely two solutions, but we don't know if they're real or complex, but we are going to move on to using the quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac. Okay, and I'll get the ruler out to put the top on that. Okay, we're going to need that ruler again because we're going to divide everything here by 2 times a. I always like to take just a moment here and write out what a, b, and c are. A, b, c. That way we don't get confused. So a, in this case, is 1. B is negative 2. And c is 4. Okay, and now we're just going to plug it in. So x equals negative b. Well, that would be negative negative 2. So I'm going to write it all out. Negative negative 2 plus or minus the square root of b squared, so that's going to be open parentheses, negative 2, close parentheses, squared, minus 4, open parentheses, 1, close parentheses, open parentheses, 4, close parentheses. Let's get the top on our radical sign. Okay. And then we'll move down here, get a big fraction bar, and then do 2 times a, which in this case is just 2 times 1. Okay. So now we can start to really get at this. So negative, negative, so make positive. So x equals 2 plus or minus the square root of, and now we remember negative 2 squared would just be 4. So 4 minus, and then we have to be careful here. Okay. So order of operations is extremely important at this stage. At this particular part, it always gets people screwed up. So remember PEMDAS. And I know you do remember PEMDAS. I'm just writing it out. Please excuse my dear Aunt Sally, parentheses, exponent, multiplication, division, addition, subtraction, which means we're going to do the multiplication part before we worry about the subtraction part. Okay. So 4 times 1 times negative 4. It's going to give us negative, this is very important, it's going to give us negative 16. Okay. See, now if you did it, if you hadn't paid attention to the order of operations, you may have not quite got that. You might have missed that. So it's wait, I missed it because I already put the minus sign. So wait, hold on. So it's 4 times 1 times 4 times essentially negative 1. So this is like 4 plus, and then negative 4 times 1 times 4. Like if that helps understand why this gets confusing. So this is negative 16. So what we end up with is 4 minus 16. Sorry for the confusion there. I thought I was being clever. So now that I know that what is called the discriminant, which would be this subtraction here, is going to be a negative number. Now that I know that the discriminant, that's the thing underneath the radical sign, is negative, I know that I'm going to have complex solutions. So it doesn't matter what goes on with the rest of the problem. We're going to end up with imaginary and real components in our solutions. So we'll divide here by 2. All right, we'll keep going. Okay, so x equals 2 plus or minus, and now it's going to be the square root of 4 minus 16. That's going to give us negative 12. So the square root of negative 12, okay, all divided by 2. Now we're going to be able to simplify this radical. So don't worry about this. You have over here in side work. Let's just take a little mental break. Just chill out and remember that you have the square root of negative 12, right? Okay, so this can be rewritten as the product of the square root of negative 1 times the square root of 12. Okay, now here's a little rule. We have to remember this rule. The square root of negative 1 is equal to the imaginary number I. Okay? So as long as you remember this rule, then this becomes pretty simple. So now, let's get back to our problem. The square root of negative 12 is going to be equal to I times the square root of 12. Now the square root of 12 can be simplified. So we need to simplify that radical. So we're going to take 12 and we're going to break it down. So first we've got 1 times 12. We're trying to break it down into prime factors. 1 is not a prime factor, but I just write it out anyway. Then we have 2 times 6. And then we have 2 times 3. So all of our prime factors, it's going to be, here are your prime factors, 2, 2, and 3. All right? So we need to rewrite this now. The square root of negative 12 is equal to I times the square root of 2 times 2 times 3. All right, now why is that important? Because whenever there are a pair, right, it's the second root, yeah? So whenever there are a pair of numbers, we can extract them from the root and put them outside. I'll show you what that looks like. So another step here, we have the square root of negative 12 equal to, now I'm going to pull a 2 out. It's like almost like reverse distribution. 2 times I times the square root of the only remaining term, which is going to be 3. Okay, so let's bring that thing that we just did, let's bring that back and stick it here. Okay, and let's see what we have. So now we have x equals 2 plus or minus, and now we're going to write this over here. We're going to write this thing in here. Okay, plus or minus 2i square root 3 all over 2. And now there's a beautiful thing that's happened. Notice that in every term, we have a 2. So there's a 2, a 2, and a 2. So they can all be canceled, right? So that simplifies things quite a bit. Now we have x equals 1 plus or minus I times the square root of 3. And then over nothing, over 1, right? So here are your two solutions. X to the first is going to be equal to 1, and then we'll do the plus, and then the proper notation here is going to be to write the square root term, then I. So 1 plus square root 3 I. Okay? And then your second solution, x2, is going to be 1 minus square root 3 I. And those are your two solutions. So they happen to be what we call complex solutions, which means that they exist in the complex plane. And I could certainly draw that for you, but it seems a bit outside the scope of this problem. So we'll just leave it there. I hope this was helpful.